On March 16, 2026, our solar system will witness the most perplexing visitor engaging in an unexpected event at Jupiter. Imagine this scene. The entity known as 3 Atlas will approach the Jovian realm, positioning itself with an unsettling mathematical exactness in a particular section of space. Yet, what breaks every assumption is that it's gradually decelerating near the gas giant with a precision that feels intentional, almost deliberate. It's neither diving into the planet nor slingshotting away. Instead, it's smoothly moving toward the farthest limit of Jupiter's gravitational influency, narrow frontier where the planet's gravitational pull ultimately surrenders to the sun's force. Its placement is so deliberate that it seems less like a random cosmic occurrence and more akin to a calculated halt. No documented natural comet has ever exhibited this level of precise navigational control, leaving astronomers staring at their screens, grappling with one unavoidable question: what or who is guiding its journey? If the accepted principles of physics can't adequately explain this trajectory, then what hidden force is dictating its next course of action? The Odyssey of 3 Atlas has evolved into an extraordinary modern, astronomical conundrum. Its rendezvous with Jupiter began long before we observed the subtle alterations in its behavior. Initially, when it caught our eye, it simply appeared as a faint dot racing through the interstellar void, following a textbook hyperbolic trajectory that scientists would anticipate from an unremarkable traveler. Its speed, angle, and characteristics were perfectly ordinary. Researchers noted it as just another fleeting visitor, destined to zip past and disappear into obscurity. However, everything soon changed. As it ventured closer to the sun, its actions began to deviate from the expected patterns. That slow but steady divergence has now become the heart of a heated scientific discussion. Is this object merely responding to the conditions of space, or is it actively directing its own path? The intrigue deepens when we observe how Atlas reacted to solar radiance. Following its closest approach to the sun, it experienced a slight yet crucial non-gravitational acceleration, a faint nudge. While the force was subtle, its trajectory was astoundingly precise, perfectly guiding it towards the position it now occupies. We've witnessed comets get affected by jets of vapor in the past, yet those outbursts tend to be chaotic, random, and asymmetric, resulting in wobbles rather than orderly adjustments. Atlas is different. This distinction has led many to believe that it is not merely a passive rock. It may harbor internal mechanisms or possess an unfamiliar structure. This conclusion is supported by a worldwide network of more than 200 observers. Each emerging dataset reinforces the same observation. Atlas is no longer on a route governed solely by gravity. Every refined model indicates its altered path, converging like a laser beam onto the edge of Jupiter's gravitational sphere of influence. The timing is uncanny. The exactness is disquieting. The consistency is irrefutable. This is not a random meander. It's a meticulously calculated journey. Adding to the peculiarity is Atlas's behavior during its approach. When subjected to intense solar heating, most interstellar bodies fracture, fragment, or rotate uncontrollably. Atlas, however, demonstrated the opposite. It maintained its integrity, navigating with a tranquil, steady composure. This smooth, controlled motion suggests its internal makeup is anything but typical, perhaps allowing it to withstand forces that would typically obliterate ordinary comets. So, could the current maneuver around Jupiter be merely a freak occurrence? The evidence points to no. It appears to be the result of a lengthy series of delicate adjustments that commenced months ago close to the sun. This leads to a profound question. What kind of influence can sustain such a steady, impeccably aimed trajectory across billions of miles of empty space? The figures behind this approach may be the most astonishing aspect. It's projected that Atlas will pass Jupiter at a distance of roughly 33 million miles. Yet, the latest computations reveal it converging to within just 35,000 miles of that precise gravitational balance point. In practical terms, this equates to an accuracy margin of just 1 in 26/0, a level of precision that rivals, and at times surpasses, our own engineered space missions. To comprehend how absurd this is, picture throwing a dart from London and having it land flawlessly in the bullseye of a board situated in Tokyo. Such accuracy isn't a mere coincidence in nature. Interstellar objects typically tumble unpredictably, with their paths becoming increasingly vague over time. Atlas defies this norm. With each update, its predicted trajectory grows narrower, honing in on a singular, razor-sharp conclusion. This growing certainty isn't merely a detail. It illustrates that the object is on a clear, stable course, devoid of the jittery, chaotic movement characteristic of a natural comet. The data implies this perfect alignment didn't gradually unfold, but rather snapped into place sharply after its solar flyby. That slight acceleration at perihelion provided precisely the adjustment required to thread the needle toward Jupiter's Hill sphere. Had it been slightly stronger or weaker, Atlas would have missed its target by millions of miles. The chance of a natural outburst providing exactly the correct push, in precisely the right direction, at precisely the right moment, is exceedingly small. This is why researchers are beginning to wonder if traditional physics is sufficient. Its behavior resembles less of outgassing and more of a deliberate course correction typical of spacecraft navigation. Moreover, its chosen endpoint, the Hill sphere boundary, is in itself unusual. It's not a goal natural objects typically aim for. Rather, it's an abstract line, a delicate threshold. For an object to not only locate it but glide along it with such assurance appears deliberate. It resembles a strategic approach to a point, where opposing gravitational forces negate each other, classic strategy in mission design for energy conservation. When you consider the incredibly minute margin of error, the abrupt adjustment near the Sun, and this peculiar destination, a clear picture begins to emerge. This is no ordinary trajectory. Something is keeping this object tethered to a precise mathematical line through the void. If this is mere coincidence, it is one of the rarest we've ever encountered. If it isn't, the ensuing question changes everything. What mechanism can guide an interstellar visitor with such impeccable timing and pinpoint accuracy? Jupiter's Hill sphere stands as one of the most critical gravitational structures in our solar system, a region where small shifts in velocity can lead to drastically different outcomes. It's already a significant challenge for our most advanced technology to reach this boundary. So witnessing an unidentified object navigate it with comparable precision raises deep inquiries. 4 primary explanations are currently under discussion. First, measurement error. However, independent verification from global sources virtually eliminates this possibility. Second, an unusual but natural outgassing event. This would necessitate perfectly timed, consistent jets over vast distances, a statistical longshot. Third, pure happenstance. Given the meticulous precision involved, this seems like the least satisfying explanation. Finally, there's the fourth. The object might be interacting with its surroundings in a controlled or semi-controlled manner. This does not automatically imply a high-level probe. An exotic internal design could facilitate steering using sunlight or internal reactions. Some theorists suggest an exceptionally advanced civilization may utilize gravitational boundaries like Jupiter's Hill sphere as navigational waypoints. While there's no direct evidence, Atlas's behavior keeps that possibility alive. None of these explanations fully resolve the enigma. So what next? As Atlas approaches, 3 potential scenarios could unfold. First, it could break apart under Jupiter's tidal forces, revealing its inner mysteries. Second, it might release smaller objects or particles as a payload drop, igniting heated discussions. Third, and most surprising, it could execute another course alteration upon reaching the boundary, demonstrating acute responsiveness to the gravitational landscape. This is not merely a visit, it's verification. Whichever scenario materializes will redefine our understanding of interstellar travel. What began as a seemingly random drift now appears to be choreographed. The precision, the timing, the poisal indicate a moment that could unveil truths far beyond what any comet could reveal. The ensuing weeks could drastically alter our comprehension of what it signifies when something emerges from the vastness between the stars. If this pause at the edge of Jupiter was orchestrated, one urgent question arises. What is Atlas poised to do next? Share your thoughts in the comments. If this exploration into the unknown captivated you, please show your support. Like this video, share it with someone curious, and subscribe to Astro Atlas to stay updated as this cosmic mystery unfolds.